Guys, you asked me for a whole exam. I'm not going to give you a whole exam, but I will give you some problems that I think you just should focus on. I've looked through this test now quite a few times, and I have to tell you that I don't see anything on here that's a challenge. I think the answers come out to be fairly nice. You know, when answers come out to be kind of ugly, like an optimization question might have a fraction and a radical at the end, but everything else looks really good. There's no, weird fractions you got to plug in to get the max and mins or anything like that. The numbers come out to be nice. So I went through and just kind of found some things I think we could just go over and talk about. There's 7 questions here. Um, you can choose to download the file. You can just watch the video, write it on another sheet of paper, and just kind of go through them, whatever you really feel like you need to do. So let me go through this here. And if you've got questions, you can still email me. And if there's something that's not on here that wasn't addressed, but I would go through your packets. That's why I did not collect them, and just see what stuff that you think you might need to go over, and let me know. But this one here is a second derivative question, so I wanted to do this one because I know that the first derivative is just doing a chain rule, but that second derivative is going to be a product rule, and it gets kind of messy. Every problem I put on here, I tried to make a little bit harder than the one that was on the test. So there might be like a little extra thing in these questions. So if you can get through these, you'll be absolutely fine. All right. So finding the first derivative, this is just going to be your quotient rule. Well, not quotient rule. Geez, chain rule. 2/3 4x squared minus 1 to the 1 less. So you leave the inside alone. And if you subtract 3/3 from this, you're going to get negative 1/3. Okay? And then you still need to multiply by the derivative of the inside piece right here. So we've got to take this inside piece and find its derivative. So that's going to be 8x minus, 8x, just right, because the 1's going to cancel out when you take the derivative. Okay. So now we have to find our second derivative. What's left over is a product rule. So we have this first term right here, and this is the second term. You can leave it just as it is and do the second derivative. You don't really have to clean it up, and I don't think many of you will. So the first would be, the 2/3 4x squared minus 1 to the negative 1/3 times the derivative of the second, which is 8, plus the second, 8x, times the derivative of the first, which is just another chain rule. So we have negative 2/9. Let me write that here. Sorry, you know what? Let me go back here. Okay. All right, so we have negative 2/9. That's what you get when you multiply this negative 1/3 times the 2/3. Leave the inside alone again, 4x squared minus 1. And then we have to subtract 1 from negative 1/3. So we're taking 3/3 away from negative 1/3. That's leaving us with negative 4/3. And then we still have to multiply by the derivative of the inside again, which is another 8x. Let me fix that. And there you go. So that would be the final answer. These answers will be ugly, and you don't really have to do anything besides find the second derivative and just write it out. So that would be how you would leave the answer. So take a moment, look through that, see if you get it, and if you don't, again, send me questions on this. All right, the next question is finding the point on the graph where the tangent line is horizontal. So this question really is the same exact thing as if I had asked you to find the derivative to find max and mins. So you would do your y prime, and you'll get negative 8x plus 24. You're going to hear my cats running around here chasing each other today. I don't know why, they're crazy. There you go. There. I don't know if you could hear that, but wonderful. All right, so we take the derivative, we set it equal to 0. So we get negative 8x plus 24. We solve this for x. I'll save a step here. You get 8x divided by 8. You get x is 3. So we put 3 back into the original. Y is equal to negative 4, 3 squared plus 24 times 3 minus 3. On your exam, make sure you show like the substitution steps. I worry that some of you guys are just going to write down numbers and it may look like you did too much in the calculator, even though this is one where you could probably do that or just do it in your head. But yeah, just show at least the substitutions. So the first one, you're going to get negative 36, right? You got 9 times 4, and then 24 times 3 is 72, so plus 72 minus 3. So minus 36 minus 3 will give you 33. So the point on this graph would be 3, which is our x value, comma 33. The idea of it being horizontal to the tangent line means the slope is 0. So that's where the connection comes in. To horizontal tangents have 0 slopes. Okay, so there's that question. I know we went over that recently. Next one is a problem where you want to show, first of all, that the limit would give you 3 minus square root of 9, which is 3, which is 0. And then, oh, actually, I screwed this up. Hold on. Let me edit it. I just realized that. I made these quick. All right. Hold on. Let me go here, take off the draw. And I should be able to switch this. This should be 81. Okay. There we go. And if we put 9 in here, 9 squared is 81. 81 minus 81 is 0. So this is grounds for L'Hopital's rule, right? All hospitals, whatever you want to call it. So if we did that, you would want to put the equal sign with the L, and we're taking the derivative of the numerator. So let me write the limit. And the numerator would be negative 1 over 2 radical x, right? Because this 3 is gone, the negative sign stays. The denominator is 2x. Now we would substitute 9 in. We're going to get negative 1 over 2 times that square root of 9 all over 2 times 9. Make sure you're not writing the limit here after you've already are now substituting in the number, because we're putting 9 in here and we're putting 9 in there. Okay, so this equals negative 1 over 2 times 3, which is 6, divided by 18. You could put the 18 over 1, and now you have negative 1/6 times 1 over 18. Okay, and so this is just a quick multiplication. So you have 18 times 6 is 108. Negative 108. And so that's your limit. You should try these in your calculator. Make sure that you get the same answer when you do that. But again, this is done using L'Hopital's rule. Now you could actually multiply by the conjugate of this numerator, top and bottom, put the denominator in parentheses, and then simplify the numerator. You're going to probably want to factor this into, x plus 3, x minus 3, x plus 9, x minus 9. Let me say that again. And then the x plus 9 or the x minus 9 will cancel with the numerator. It'll probably be a negative 1 because 1 will be backwards. It'll be like 9 minus x and x minus 9 on the bottom. So you could do it that way, but I think L'Hopital's rule is really the way you want to go, especially when we start getting into Calc 2. For those who are taking that next year, we're going to pretty much stick with L'Hopital's rule. Okay, next one, number 4. This is a derivative involving e, and it's just a very long chain rule, so I wanted to go through that. So anytime you have e to the x, hopefully you remember that the derivative of e to the x is just, or derivative of e to the anything is just e to the anything, so it's e times cosine, sorry, I'm not really good with this pen, and I haven't had coffee yet today, so you know how I am when I don't have coffee. Okay, so you just leave everything alone. Then you multiply by the derivative of this exponent, which is a chain rule. 2, leave the whole inside alone. And then to the first. Now, you don't have to put that there, but I will. Then times the derivative of just this whole thing. Derivative of cosine of 2x is negative sine of 2x times 2, and then the derivative of 5 is 0, so you would leave like that, and that would be your derivative. Nice, long, stretched out chain rule. And this is not in the exponent. Like this is actually written at the same level as this, e, the base. Okay. All right. So there's that. And let's go to the next one. The next one is an implicit, but it's involving ln of x. This will be fun to write with a marker. I'm going to try my best. I'm going to work this real well here for you guys. All right. So this is implicit. So the derivative of 4x is 4. The derivative of ln of anything is 1 over the anything times, in the numerator, the derivative of the inside, which is just 1 plus, and then the derivative of y is dy dx. This is equal to 6y dy dx, and then the 1 is just gone. Okay, we are going to want to distribute here. We're going to distribute this into both of those terms there as a fraction. So when you do that, you end up with 4 plus 1 over x plus y. Okay, that's the first distributing part. And then plus, and I would just put this dy dx on top. dy over dx over x plus y. And then equals 6y. I don't like that y. And then dy dx. Okay. Next thing I'm going to do is I'm going to bring this dy dx over here, factor it out, and I'll show you that in one step. So I'm going to be left with 4 plus 1 over x plus y equals, and then on this side I'm going to have a dy dx that I'm going to factor out, and it's factoring out of the 6y minus 1 over, because I'm subtracting this over, x plus y. And of course, the last step is to divide this parenthesis underneath the left-hand side. So I'm left with 4 plus 1 over, there we go, x plus y. And that's all over 6y minus 1 over x plus, that's terrible. I could do this, guys, right? Okay, here we go. X plus y. All right, so I divide this whole parenthesis underneath, and equals dy dx. Can you hear my cats? I really wonder. I'm going to have to go back and listen to this video. Ugh. Bunch of filthy animals. Okay, so there you go. That's how you would do the derivative of that. It's not that difficult. It's just a little different because we're dealing with this distribution of a fraction into other fractions over here. So it looks kind of weird, but That's the way I would handle it. I would always keep this on the top and not put the dx on the bottom and try to factor. I think it just might confuse you. Okay, that leaves us with a couple more problems I made up here. This is an integration question involving something that is underneath a radical. So anytime you see this, this is going to be u substitution. All right, and you're definitely going to have a u substitution. It's something we worked on right at the end, is like the last thing we did. So you're going to let u equal the 4x squared plus 2x. Anything that's underneath the radical, that's going to be the u. The du is the derivative of this, which is 8x. Try that again. 8x plus 2. And the 8x plus 2 is what we have here, and then there's a dx, which is right here. So everything is covered. This thing right here is du, and underneath is u. So we end up with the integral of radical u du. And that's really u to the 1/2 du. So when we take the integral of u to the 1/2, we get u to the add 1 to the exponent, so that's 3/2. And then we multiply by the reciprocal, which is 2/3. 2/3. And then plus c. Don't forget that. Over under 6.5. Okay. Then we're going to replace this u with the 4x squared plus 2x. So it's 2 parentheses 4x squared plus 2x, and then parentheses to the 3/2 all over 3 plus c. There you have it. Okay. All right. So now we look at our last question, which I've come up with here, which is integration involving ln. And anytime you have an integral that involves ln, you should always let u equal the ln part. So we're going to let u equal this thing. And du would be 1 over x times 1, the derivative of x, dx. Okay. Now I got to go back and look, because I think the question on your exam doesn't have an x to the 4th, so I'm going to change this. Let me go back here. And I'm going to edit this. I believe this is probably going to be something like 1 over x. I was kind of getting this mixed up with my Calc 2 class where we do something called integration by parts. So I think this will be something just like 1 over x. That'll be better. It'll simplify quite simply for you. You're not going to have anything that's out of the ordinary. So here you can see that our du is 1 over x dx, which covers that part there. All right, so this is your du. So we end up with just really the integral of u, and this is du, or as I call it, so do. All right, and if we integrate this, we get x squared over 2, and we put our plus c here. And since u was ln of x, this would be ln of x squared all over 2 plus c. Okay? Now I'm going to save this file to my computer as the solution, and the answers to it. So I'll call the solutions. I'll upload both files to my teacher page, and you can download the blank one, and you could also download the, the completed one if you want to print that one out too and go over it. All right, so here you go. What happened to my limit question there? Where did that work go? It disappeared into thin air. Wait. Oh, I see what's happening. Sometimes my computer lags a little bit. Okay, it's there. There it is. It's there. All right, guys. I saved this. I'll stop this horrendous video. And if you've got questions, please don't hesitate to ask.